This is the first solving equations video. I am Ms. McCool and I am going to be working with you on our learning target. I can solve a two-step equation using inverse operations. This video goes with the Equations 1 worksheet. And if you are watching this video, you should have already completed the top portion of the Equations 1 worksheet. In that top part of the worksheet, you are reviewing your 6th grade one-step equation skills. When we are solving a one-step equation, we are figuring out what operation is being performed to x in the equation. For example, in this case, we are adding 7 to the variable to n. And then we are going to undo that operation using the opposite, which we call the inverse operation. So in my equation, I had my variable and I added 7 to it. So I need to undo that addition with subtraction. In this second example, my original operation was subtraction. I subtracted 10 from r. So I need to undo that subtraction with the opposite, addition. Of course, I am showing the plus 10 to both sides of the equation in order to maintain my balance. Here we are dividing by 2, and so we have an inverse operation of multiplication. Finally, 13 times a, the original operation was multiplication, so I need to undo that multiplication to get a by itself using division. I hope that you made sure that you understand what we mean by the check when you have solved an equation. The check is when you plug your solution or your value for the variable back into the original equation and make sure that it's true. So here we plug 24 in for r, right here. And then we made sure, hey, does 24 minus 10 equal 14? Yes, it does. 14 equals 14, and then the most fun part, check. And you did that for each of them. For example, here, your solution was a equals 2. You plugged 2 in for a, and see, does 26 equal 13 times 2? 26 equals 26, check. And that is what we mean by performing the check, which sometimes will be required in algebra and sometimes will not be. Moving on to our new information, a two-step equation. Now, when we're looking at a two-step equation, we are performing 2 operations rather than 1 to our variable, to our x. In this example, x is being multiplied by 4. That's our first operation. And then we are adding 3. That's our second operation. And that's actually the order those operations are being performed in due to PEMDAS. We multiply by 4, and then we add 3. So just like if this were a one-step equation, we will be using inverse operations to get x by itself. And just like in our one-step equations, we're going to think about the opposite of our operations. So for multiplication, our inverse is division. For that addition, our inverse will be subtraction. So we will be dividing by 4 and subtracting 3, as you see. The big question is, in what order do I perform those operations? If you just want a rule of thumb, the rule of thumb is, hey, add or subtract first, and then multiply or divide. So in all of the equations you're doing on this worksheet, you will be adding or subtracting, and then you will be multiplying or dividing. This is something we will be going into a lot more detail on next year, and there are some different situations. If you need a little more background rather than just memorizing, hey, add or subtract, then multiply or divide, you can think about going in the reverse of PEMDAS. So the normal order of operations, you multiply or divide, and then you add or subtract. That's what's happening here. I multiply by 4, and then I add 3. So when I am undoing that multiplication and division, I need to do that in the opposite order of the order that it was performed in. So PEMDAS, I multiplied and then I added. When I'm undoing that, I need to go in the opposite order. I need to subtract and then divide. So 2 ways to think about it: memorize, add or subtract, then multiply or divide, or think about it, reverse order of PEMDAS. And again, we will be giving you some more intuition behind that later on. Okay, so we are going to, or I am going to, work through these 4 problems on the front of your worksheet, starting with the first one, 8x minus 7 equals 33. You may have already completed this problem, and you can just go ahead and watch this to make sure that my work and process lines up with yours. If you haven't, then great, follow along with me. Okay, so we have 8x minus 7 equals 33. My two original operations are multiplication and subtraction. So my inverse operations will be division and addition. We're going to be dividing by 8 and adding 7. The question, in what order do I perform those inverse operations? If you memorized it, you add first. If you want to think about it, opposite of PEMDAS, we do the opposite of multiplying or dividing and then adding or subtracting. So we go in reverse order, adding first. I just want to quickly talk to you about a trick that some of you may have learned, which is you can just move that 7 over and go right to here. That is a trick that does work in this case. That is a trick that is not, I repeat, not sanctioned in any of our algebra classes. You will not receive any credit for this problem if you use that trick. It is not our algebra process or strategy. So if you know that trick, it's great for maybe quickly checking your work, but please get out of that habit because you will be very sad with your grades next year, okay? So no tricks. We are going to instead use our algebraic process of solving using inverse operations, maintaining the balance on each side of the equal sign. Okay, we already discussed we're going to add first. I'm going to add first. What am I adding? I'm adding 7. So that on the left-hand side of my equal sign, I have 8x minus 7 plus 7. Some of you like to cross that out because minus 7 plus 7 leaves us with 0. That is optional. You don't have to show that crossing out. So we added 7 to both sides. 8x minus 7 plus 7 just leaves us with 8x equals 33 plus 7, which is 40. You should have everything on your paper other than this is optional, and actually this vertical line is optional. I often forget to draw that vertical line, so that is up to you. We are now performing our inverse operation of division. 2 ways to show that. This is totally fine. Dividing by 8. That is not how I normally show it. Normally I show my division using a fraction bar. That looks a little more sophisticated to me, so I'd be happy if you're choosing a method, choose that one for showing division. So we are left with x equals 40 divided by 8, which is 5. Boxing or circling my final answer, and that is my solution to the equation, x equals 5, showing each of my 2 inverse operations. If we told you you had to show the check, you would plug that 5 back in for x and make sure that it makes the equation true. Does 8 times 5 minus 7 equal 33? Let's check. Does 40 minus 7 equal 30? 33? 33 does equal 33, yay! And I do kind of like doing the check because I get to do that check mark. All right, so there is our first 2-step equation. Moving on to the second example on your page. R divided by 6 plus 1 equals 8. So our original operations, division and addition. My inverse operations will be the opposite of division, multiplication, the opposite of addition, subtraction. Thinking about which one to do first. Did you memorize it? Hopefully you have a good sense of this right now. We are going to be subtracting first, opposite of what we would do according to PEMDAS. PEMDAS? PEMDAS? I don't know. Okay, first inverse operation. I'm going to subtract 1 from both sides. You should always be making sure whatever you do to one side, you do to the other. You need to show this 2 times. I'm subtracting 1 from the left-hand side. I'm subtracting 1 from the right-hand side. R divided by 6 plus 1 minus 1 leaves me with R divided by 6 equals 8 minus 1, which is 7. We now have a 1-step equation, which hopefully you are super, super comfortable with. R divided by 6 equals 7. My inverse of division, multiplication. It is okay to write times like that, I guess maybe, but I really don't like it. I'd really not like you to show it that way. Times 6, when you do the little times with an x, you may get confused and think it's a variable. You can also, in this case, show the times 6 up here. I am not going to do it that way, but that is totally fine as well. That will be a little more common next year, actually. So times 6, we have r divided by 6 times 6, which leaves us with r. 7 times 6 is 42, and that is my solution to the equation. R equals 42. If I asked you to check, which we have on the worksheet is optional because there's not a lot of space, we would substitute 42 in for r. 42 divided by 6 is 7. Does 7 plus 1 equal 8? Yep, check. Again, this part does not have to be on your worksheet when you show it to your teacher because there's not a lot of space. It's just when you're taking an assessment, or if we ask you to, it's a really good idea to make sure that your solution does in fact work. Next example, m divided by 3 minus 4 equals 5. What is being done to my variable? I'm dividing by 3. So my inverse operation is going to be multiplication. I am subtracting 4. So my other inverse operation is going to be addition. Again, kind of the intuition behind why we are adding first is we had our variable, this mystery number, we divided by 3 and then subtracted 4 because that's the correct order of operations. That ended up with a value of 5. So we want to kind of retrace our steps going in the opposite order. So m divided by 3 minus 4. We're going to add 4 and then multiply by 3. So adding 4 first, that gives us m divided by 3 minus 4 plus 4, which is just m divided by 3, equals 5 plus 4, which is 9. One-step equation, yay. Opposite of dividing by 3, multiplying by 3. M divided by 3 times 3 just leaves me with m. Again, that's kind of the point. We're using the opposite of this division to get rid of it, so we're just left with m. M equals 9 times 3, which is 27. That is the solution to this two-step equation. If I don't ask you to do the check, I would still really, really super suggest that you do it in your brain. So in your brain, plug in 27 for m. 27 divided by 3 is 9. 9 minus 4 is 5. Yay, I have checked that solution mentally. Final problem on the front side of this worksheet. 3 plus 6n equals 27. Again, I want to reiterate this, not sanctioned. Don't do it. A lot of your parents learn this trick, and you've learned this trick somewhere else. It's not bad. It's just 0 credit, so don't do it. We are using our algebra strategy of inverse operations. The inverse operations being subtraction, because we added 3, and division, because we were multiplying by 6. In what order should I be performing those operations? Hopefully, you super know at this point. I'm going to be subtracting first. So subtracting 3 from both sides of your equations to maintain that original balance. 3n plus 6n minus 3, those two guys, 3 minus 3 is 0, or 3 plus 6n minus 3, that ends up with a 0. 6n equals 27 minus 3, which is 24. One-step equation, 6n equals 24. You can do that division. I'm not doing that. I'm doing my very sophisticated fraction bar version. 6n, or 6 times n divided by 6, leaves me with n. 24 divided by 6 equals 4. That is my solution, meaning the value of my variable that makes the equation true. If I plugged in 4 for n, order of operations, I would multiply first. And yes, indeed, 27 equals 27. Okay, that is the end of my work with you. It's now your job to turn to the back of the worksheet and show me, or any of your math teachers, that you can successfully and correctly solve a two-step equation. The answer key for this back of the worksheet is on the website, so you and your parent can go ahead and check your work and your answer with the emphasis on your work. Or you can bring your worksheet to one of the math teachers in our building. The only thing that would be optional is that vertical line, but we need to see 2 inverse operations for each problem, one on the left-hand side, one on the right-hand side, 2 times. So please, please, please focus on making sure you are showing your work correctly, and of course that you are also matching my answer.